Hello students, I am your Aishwarya and this is Sankalp Learning Solutions. Welcome to session 2 of coordination chemistry. So basically now last class alli ಏನು discuss ಮಾಡಿದ್ವಿ, we had discussed what are coordination compounds, what are its applications, ಮತ್ತೆ we had discussed some of the important terminologies regarding coordination compounds. Yes, ಇದನ್ನ ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಬೇಕು, coordination compounds ಬಗ್ಗೆ ಸ್ಟಡಿ ಮಾಡಬೇಕು, ಫರ್ದರ್ ಹೈಯರ್ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡಿಂಗ್ಸ್ ಆಗಬೇಕು ಅಂತಂದ್ರೆ ಬೇಸಿಕ್ ಥಿಂಗ್ಸ್ ನಮಗೆ ಕ್ಲಿಯರ್ ಆಗಿರ್ಬೇಕು. In that, the last thing what we had discussed was regarding ligands. Howda? So ligands ali we had seen what are ligands, what are the different types of ligands. How do they are donor atoms? Yes. So they give electrons. They share rather than saying give. They share the electrons to the central metal atom anta anbodu. Howda? Fine. So ligands, the molecules or ions which are coordinated to the metal atom or ion. So metal atom will be there at the center, and this metal atom will be attached to, depending upon the number complex condition, ಅದು ಎಷ್ಟು ಲಿಗ್ಯಾಂಡ್ಸ್ ಬೇಕೋ ಅಷ್ಟು ಲಿಗ್ಯಾಂಡ್ಸ್ ಅಟ್ಯಾಚ್ಡ್ ಆಗಿರುತ್ತೆ. ಅದಕ್ಕೆ ನಾವು ಕೋಆರ್ಡಿನೇಷನ್ ಅಂತೀವಿ, ಕೋಆರ್ಡಿನೇಷನ್ ನಂಬರ್ ಅಂತೀವಿ. ದಟ್ ಆಲ್ ವಿ ಹ್ಯಾವ್ ಸೀನ್. Example is being given here, K4FeCN6. 6 CN ligands are being attached. What is the CN stands for? CN stands for cyanide group. So 6 cyanide groups, they are coordinated by Fe+2 and they are called as ligands. So ligands can be positive ions, can be negative ions, they can be neutral molecules. Maximum agi nodidaga most of the cases they are negative ions antivi, anions, athwa most of the times they are neutral molecules. Like for example, NH3 togoli, H2O togoli. Yes, these are neutral molecules, but under very rare cases we have positive ions also. And these ligands are Lewis bases anta antivi. So Lewis concept only, Lewis acid ಮತ್ತು base ಬಗ್ಗೆ ಕಲ್ತಿದೀವಿ. What is Lewis acid? Lewis acid is a electron pair acceptor. Lewis base, it is an electron pair donor. One which donates the electrons is called Lewis base, and one which is capable of accepting the electron pair is called Lewis acid. So ಇಲ್ಲಿ ನಾವು ಕಾಂಪ್ಲೆಕ್ಸ್ ಅಯಾನ್ ತಗೊಂಡಾಗ ಸೆಂಟ್ರಲ್ ಮೆಟಲ್ ಆಟಮ್ ಮತ್ತು ಲಿಗ್ಯಾಂಡ್ ಇದೆ. ಸೊ ಸೆಂಟ್ರಲ್ ಮೆಟಲ್ ಆಟಮ್ ಆಕ್ಸ್ ಆಸ್ ವಾಟ್? ಇಟ್ ಆಕ್ಸ್ ಆಸ್ ಲೆವಿಸ್ ಆಸಿಡ್, ಯಾಕಂದ್ರೆ ಅದು ಎಲೆಕ್ಟ್ರಾನ್ ಪೇರ್ ಅನ್ನ ತಗೊಳ್ತಾ ಇದೆ. Actually, it is not accepting. It is being shared by both of them. ಅದಕ್ಕೆ ನಾವು ಯಾವ type of bond ಅಂತ ಅಂದ್ವಿ? We said coordinate bond is there between the ligand and the central metal atom ಅಂತ. And ligands, what they are doing? They are sharing ಅವರಲ್ಲಿರುವಂತ lone pair of electrons. Last class ಅಲ್ಲಿ ನೋಡಿದ್ವಿ ನಾವು. The particular ligand will be having a donor atom, and that donor atom will be having a lone pair of electrons, and that will be donated to the central metal atom. Therefore, ligands are Lewis bases and central metal atoms are Lewis acids. Okay, types of ligands nodidvi. We have seen types of ligands: monodentate ligands ಮತ್ತು polydentate ligands. Monodentate ligands are also called as unidentate. Mono or uni stands for one ಅಂತ ಅನ್ಬೇಕಾದ್ರೆ we say mono or uni, right? And polydentate ಅಂತಂದ್ರೆ ಏನು? Poly stands for multi, many ಇದ್ದಾಗ. Okay, then we have third type of ligands also, which we are called as ambidentate ligands also. Ambidentate ligands ಅಂತಂದ್ರೆ we have already seen, if a ligand has two or more donor atoms and the complex is formed, only one donor atom is attached to the metal. For example, you can see here nitro group. Last session alli kuda ನಾವು discuss ಮಾಡಿದ್ವಿ, but here you can see nitro NO2 is a ambidentate ligand. Andre it will be if nitrogen is going to donate its lone pair of electrons to the central metal atom, we call it as nitrito N. And if oxygen is going to donate its lone pair of electrons, then we call it as nitrito O. Nitrito O. Oxygen will be donating the lone pair of electrons. We call it as nitrito O. So depending on that, which donor atom is going to, and complex ಅಲ್ಲಿ only one donor atom will be donating. Depending upon the need of the complex, ಯಾವ್ದಾದ್ರು ಒಂದು donate ಆಗುತ್ತೆ. You cannot say both will be donating at the same time. No, both won't be donating. ಅಂತದಕ್ಕೆ ನಾವು both ಇತ್ತಪ್ಪ ಅಂತಂದ್ರೆ we call it as what? We call it as bidentate ligand. So this is not bidentate, this is ambidentate ligand. And we had seen different examples also. NO2 ಆಗಿರ್ಬೋದು, CN ಆಗಿರ್ಬೋದು, ಅಥವಾ NC ಆಗಿರ್ಬೋದು. Cyanide, isocyanide. Then SCN, thiocyanide or isothiocyanide. Then we have mono or unidentate ligand. ಏನಪ್ಪ ಅದು definition? The donor atoms, one donor atom or one point of attachment. ಒಂದೇ site ಇರುತ್ತೆ and will donate only one pair of electrons, can coordinate with a metal ion at only one site in the complex. And these are the examples we had seen in the previous session also. So many examples we had seen. Anionic ligands ನೋಡಿದ್ವಿ, cationic ligands ನೋಡಿದ್ವಿ. Then we had also seen neutral ligands. ಇಲ್ಲಿ H2O ಕೊಟ್ಟಿದ್ದಾರೆ, you can see aqua ಅಂತ ಅಂತೀವಿ, ಹೌದಾ? H2O is an example for neutral ligand. Okay, then polydentate or multidentate ligands. So you can see here, you can see the structures clearly here. Polydentate ligands anta andru more than one. Yes, not one. Two or more donor atoms or points of attachments iddaga adu polydentate antivi, and they are further classified as bidentate, tridentate, tetradentate, hexadentate. Yes. So here we have examples. Oxalate. You can see here it is having two donor atoms, therefore it is a bidentate ligand. Ethylene diamine, EN. This is having two donor atom sites, therefore it is also a bidentate ligand. Diacetylene dioxime. It is also having two donor atoms, bidentate ligand. Here 2,2 dipyridyl. This is also having two donor atoms, bidentate. And here also acetyl acetonate, bidentate ligand. So these are examples. Then coordination number ಬಗ್ಗೆ ಕಲ್ತಿದ್ದೀವಿ in the previous class. What is this coordination number? Coordination number ಅಂತಂದ್ರೆ number of ligands, to be more specific, number of monodentate ligands at ligand atoms bonded directly to the central metal atom. It is called coordination number. So you can see here various examples I have taken here. So CONH3 6. So NH3 is a monodentate ligand. Excuse me. So how many NH3 ligands molecules are attached to the central metal? Cobalt is my central metal atom. So there are 6 NH3 molecules. Therefore, coordination number is 6. AgNH3 twice. So NH3 is again a monodentate ligand. 2 are attached to silver. So coordination number is 2. COEN thrice. EN is an example for bidentate ligand. Bidentate ligand. So 3 anta andaga it will each EN will have two sides. Hagadre 3 iddaga how much it becomes? 3. It becomes 6. So coordination number is what? Coordination number is 6. But how many ligands are there? Only 3. So this is very important. So bidentate iddaga you have to be very careful. Tridentate ittapa andare 3 ligands idava. Tridentate ide. So it's 3 into 3. So coordination number is 9. Hexadentate 2 are there. So what you will do? 6 into 2. So coordination number is 12. Like this you have to do. Geometry of the complexes, let me just brief out here. Again, we'll be studying in detail. Geometry of the complex is related to what? It is related to the coordination number. If the coordination number is 2, simple agi artha madkolli. Idu artha aitantare next complex things can be understood very easily. If the coordination number is 2, then it will have what geometry? It will have linear geometry. It will have linear shape athwa geometry anbodu. So here you can see coordination number is 2. Yes, linear geometry. If coordination number is 4, then it will have tetrahedral geometry. Tetrahedral geometry. Coordination number 5, you expect two types of geometries here. Two types of geometries. One to trigonal bipyramidal. We will see. Bere theories idave to explain the complexes and their structures. Then explain madlike bere theories idava. Our theories alli navu idanna artha madkoltivi. Like we have Werner's theory, we have valence bond theory, we have molecular orbital theory, then we have crystal field theory, ligand field theory, electronic theories. So idella theories nodta hodage we'll understand how these structures arise. Okay. So coordination number 5 iddaga, the geometries can be trigonal bipyramidal or square pyramidal, and you can look at these structures also. Coordination number 6, quite obvious, it will be octahedral geometry. It will be octahedral geometry. So what I want to say here is the coordination number will decide the geometry of the complexes. It will decide the shape of the complexes. Yav shape alli a particular complex iruttappa. Yes, then ಕಾಂಪ್ಲೆಕ್ಸ್ ಅಯಾನ್ ಬಗ್ಗೆ ನೋಡಿದೀವಿ. ಕಾಂಪ್ಲೆಕ್ಸ್ ಅಯಾನ್ ಅಂತಂದ್ರೆ ಏನು? It is metal and the ligands which is being written in a square bracket. Yes or no? So central metal ion with the number of their molecules surrounding it is called complex ion. You can see the example. Here you have Fe, central metal atom. Then 1, 2, 3, 4, 5, 6. 6 H2O molecules, monodentate ligands attached to the central metal atom. So this particular part plus 3 charge. This is called what? This is called complex ion. ಆಮೇಲೆ ಅದ್ರ ಹೊರಗಡೆ ಏನ್ ಬರುತ್ತಲ್ಲ, ಲಾಸ್ಟ್ ಟೈಮ್ ಇನ್ ದ ಪ್ರೀವಿಯಸ್ ಸೆಷನ್ ವಿ ಹ್ಯಾವ್ ಸೀನ್, ಅದು ಹೊರಗಡೆ ಬರುವಂತ ಸ್ಪಿಯರ್ ನಾವೇನಂತೀವಿ? ಅಯೋನೈಸೇಷನ್ ಸ್ಪಿಯರ್ ಅಂತೀವಿ. ಕರೆಕ್ಟ್? ಸೊ ಕಾಂಪ್ಲೆಕ್ಸ್ ಅಯಾನ್ ಅಂತಂದ್ರೆ ನೆನ್ಪಿಟ್ಕೊಂಡ್ಬಿಡಿ, ಇಟ್ ಇಸ್ ಅ ಸೆಂಟ್ರಲ್ ಮೆಟಲ್ ಅಯಾನ್ ಅಂಡ್ ದ ಲಿಗ್ಯಾಂಡ್ಸ್. Fine. So here are some of the examples which is being shown. You can see here in certain cases. In second example, nodi, Al is the central metal atom. F6 fluoro ions are being attached to the central metal atom. Cobalt 6 NH3 molecules. Here you see there is copper and there are 2 H2O molecules and 4 NH3 molecules. That means they can be different ligands also in the complex ion. ಒಂದೇ ತರದ ligands ಇರಬೇಕಂತ ಇಲ್ಲ. They can be different types of ligands also in the complex ion. Getting my point? ಬೇರೆ ಬೇರೆ ತರದ ligands ಇರಬಹುದು. Then we have coordination entity. Coordination entity ಅಂತಂದ್ರೇನು? Metal atom or ion bonded to fixed number of ions or molecules. ಅದು coordination entity ಅಂತೀವಿ. See here. So CO is bonded to fixed 3Cl and 3 NH3 ions. So 3 NH3 molecules. ಇದಕ್ಕೆ ನಾವೇಂತೀವಿ? Coordination entity. So coordination sphere ಬಗ್ಗೆ ಕಲ್ತಿದೀವಿ. So you can see here in the previous session itself we have seen. So what is this CO? CO is the central metal atom. NH3 ಏನಿದು? This is ligand. And how many NH3 are attached? 6. So this is a monodentate ligand. Therefore coordination number will be 6. Then this which is being written in a square bracket is called coordination sphere. ಹೊರಗಡೆ ಬರೆದಿದ್ದನ್ನ ಏನಂತೀವಿ ನಾವು? This is called ionization sphere. +3 is nothing but the oxidation number of the coordination sphere. This is the how the coordination compound is being represented ಅಂತ ಅನ್ಬೋದು. Then here we have something called homoleptic and heteroleptic ligands ಅಥವಾ asymmetric ligands ಅಂತಾನೂ ಬನ್ಬೋದು. So homoleptic ಅಂತಂದ್ರೆ ಏನು? When all the same types of ligands are attached, you can see this P stands for central metal atom. All same types of ligands, one kind of donor atoms attached to the metal ion are called homoleptic ligands. They are called homoleptic ligands. ಹಾಗಾದ್ರೆ heteroleptic ಅಂದ್ರೆ ಏನು? ಒಂದೇ ಡಿಫರೆಂಟ್ ಇತ್ತಪ್ಪ ಅಂತಂದ್ರೆ we call it as heteroleptic ligand. If there is one different atom, it is called heteroleptic ligand. So homoleptic ಅಂತಂದ್ರೆ same type, same kind of ligands are attached. Heteroleptic ಅಂತಂದ್ರೆ different, one or more different ligands ಇದ್ದಾಗ ಅದಕ್ಕೆ ನಾವು heteroleptic ಅಂತೀವಿ. So you can look at this example. ಇಲ್ಲಿ if you look at the first example ಅಲ್ಲಿ they have given only complex ion here. So see in this first example, Fe, the central metal atom, is attached to all 6 H2O molecules. H2O, 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 H2O. So this is an example for homoleptic. Yes, homoleptic. This is also homoleptic. Getting? This is heteroleptic. Different ligands. Artha aita? So homoleptic, same kind of ligands are there. Heteroleptic, different kinds of ligands. Adak now homoleptic complexes, heteroleptic complexes anta antivi. So here you can see the examples. Asymmetric, all three are different. All three are different. That is asymmetric. Then charge number of the complex ion. How to find the charge number of the complex? The net charge carried by the complex ion is called the charge number. So charge number nodi hege calculate madudu. For example, FeCN6 4 minus. So how do you calculate? Charge of Fe plus 2 plus entire the calculate ಮಾಡೋದಿದೆ ನನಗೆ. ಇಲ್ಲಿ 4 minus ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ. I already know it. If I don't know what is the charge, if I write it as X here, how do you calculate that? So charge on Fe plus 2 plus how many number of monodentate ligands are there? 6 into charge on Cn minus. What is the charge on Cn? It is minus 1. So therefore, Fe is plus 2. So plus 2 plus 6 into minus 1 becomes what? It is minus 4. The net charge carried by the complex ion is called what? Is called charge number of the complex ion. ಅಥವಾ ಅದಕ್ಕೆ ನಾವು oxidation number ಅಂತ ಕೂಡನು ಅನ್ಬಹುದು. Okay, fine. So coordination polyhedron. Coordination polyhedron ಅಂತಂದ್ರೆ ಏನು? The spatial arrangement. ನೀವು ಇದು ligands ಇದಾವ. 3 ligands are attached to the central metal atom. 4 ligands are attached. 5 ligands are attached. 6 ligands are attached. ಹಿಂಗಿದ್ದಾಗ how these ligands will be directed in the 3-dimensional space. So spatial arrangement of the ligand atoms directly attached to the central metal ion or atom is called coordination polyhedron. It will give a shape. ಅದಕ್ಕೆ ನಾವೇನಂತೀವಿ? coordination polyhedron ಅಂತೀವಿ. So you can see here in the first case 4 metal atoms are there. So coordination polyhedron ಬಂದ್ಬಿಟ್ಟು ಏನಾಗಿದೆ? Square planar. Then you have tetrahedral arrangement for 4 again. The coordination number is 4 again here. Then you have trigonal bipyramidal for coordination number 5 or square pyramidal for coordination number 5. And for 6 it is octahedral. So these are all called what? These are all called coordination polyhedrons. Fine. Then Sidgwick's electronic theory. What does the Sidgwick's electronic theory says? the ligand donate the electron pairs to the central metal ion and thus form a coordinate bond. How the we know this, correct? So here platinum is my central metal ion, central metal atom. Which are the ligands? See, only more the ligands there. One is NO2. There are two NO2, two Cl, and two NH3. So they are going to donate the electrons to whom? To the central metal atom. Central metal atom is my Lewis base, electron pair acceptor. Sorry, electron pair. This is acid, Lewis acid, electron pair acceptor. And these are what electron? These are Lewis base, electron pair donors. So it is going to donate electron pair to the central metal ion, and thus through what? Through coordinate bond. Andre, it will donate its lone pair such that that particular lone pair, andre avu ಎರಡು electrons will be shared by the central metal atom as well as the ligands. It will be shared by both of them. Chocolate sharing, that example I had given, it will be shared by both of them, both the central metal atom and the ligand. That such type of bond is called what? It is called coordinate bond, or it is also called as dative bond, correct? Then we have something called effective atomic number. Now, what is this effective atomic number? Yes, so effective atomic number, it is being abbreviated as EAN. EAN, this is a very important concept. We will have some of the numericals to be understood here. Effective atomic number ಮಾಡಬೇಕಾದ್ರೆ ನಮಗೆ numericals ಬರುತ್ತೆ. We need to understand how to calculate this effective atomic number. Yes, so let us see. So effective atomic number, which is abbreviated as EAN. So what is this effective atomic number? So let me write the definition. In order to explain the stability of complexes, scientist by name Sidgwick proposed this. Okay. Proposed effective atomic number. So effective atomic number generally coincides with atomic number of next noble gas. In some cases, okay? This is in some cases. In some cases. Fine. Okay. So effective atomic number is nothing but, so I'll write here, effective atomic number is equal to atomic number of metal minus electrons lost in the formation plus number of electrons gained from donor atom of ligands. Yes, this is in simple ಹೇಳ್ಬೇಕಪ್ಪ ಅಂತಂದ್ರೆ EAN is equal to atomic number minus oxidation state or oxidation number plus coordination number into 2. This is nothing but effective atomic number. ಹೀಗೆ ಬರಿತೀವಿ ನಾವು effective atomic number. So effective atomic number ಅಂತಂದ್ರೆ that was being proposed by Sidgwick. So effective atomic number is nothing but, here it is atomic number of the metal atom, central metal atom, minus electrons lost in the formation, that is nothing but oxidation number, plus the number of electrons gained from the donor atom, that is nothing but coordination number into 2. Yes, so this is, we have 2 yake because electron pair irattalla, so 2 electrons. So this is how we find effective atomic number, and we can see here effective atomic number na we can write it in the form of some simple expression. Hing baritivapa. It is written as EAN is equal to Z minus X plus Y. What is Z? Z is nothing but atomic number of the metal. What is X? Number of electrons lost during the formation of metal atom ion from its atom. ಆ ಮೆಟಲ್ ಆಟಮ್ ಎಷ್ಟು ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಕಳ್ಕೊಂಡಿರುತ್ತೆ ಅಂದ್ರೆ ಚಾರ್ಜ್ ಅನ್ಬೋದು. therefore it becomes oxidation number. And Y is what? Y is number of electrons donated by the ligands. How many electrons are donated? And here example is being taken. You can see FeCN6 minus 4. If you want to calculate the EAN number of this. So Fe oxidation state banbitu plus 2. What is the Z antandrenu? It is the atomic number. What is the atomic number of Fe? 26. Come on, let's calculate. 26Z minus oxidation state is 2 plus how many ligands are attached? Number of electrons donated by the ligands. 2 electrons per ligand. So how many ligands are there? 6. So 6 into 2 is 12. So calculate it. You will get the answer. That is nothing but 36. So this is about the effective atomic number. Let us try to understand this by taking some of the examples. Examples don't be to nodona how to understand, how to calculate the effective atomic number. Fine. Okay. So see here. Let me write here an example. Let me see how you can calculate. Okay, the example comes like this. K4 FeCN6. So this is my first example. Now, how do I calculate the effective atomic number for this particular complex, coordination complex? So I want to calculate effective atomic number. So EAN is equal to what? It is equal to Z minus X plus Y. How the Z minus X plus Y. What is Z? Z is the atomic number of what? This complex I'm going to see now. So Fe, the atomic number yes to the atomic number of the metal is 26 minus what is the charge carried by Fe? Charge carried by Fe is plus 2. Plus 2 plus how many ligands? 6 into 2. This is correct. So how much? Calculate. It becomes 36, which is nothing but the atomic number of next noble gas, that is krypton. Now the question arises how to find the charge on the metal atom. Iga, you want to calculate charge. See, K4 FeCN6, how does it splits? It splits as K plus and FeCN6 minus 4. So 4 Fe plus, so it splits like this. You want to calculate the charge of Fe. So Fe, let me keep it as X plus X into 1. 1 Fe atom ide. So plus Cn, what is the charge? Minus 1 into 6. That is equal to, what is the total charge? Minus 4. Howda? So 6x, 6 minus x equal to minus 4. How much it becomes? X equal to plus 2. So charge on Fe is what? Charge on Fe is plus 2. This is how we calculate the charge on the central metal atom. Is that clear? So this is the first example what we had taken. Now take the second example. Come on, do it with me. Let me see. So the second example is CuNH3 4 SO4. This is my complex. Yes, nomenclature adella matadona. We'll discuss about it. Now let us calculate EAN for this. So effective atomic number EAN is equal to Z minus X plus Y. What is the atomic number of copper? It is 29. It is 29 minus what is X? How much is X? Calculate mad nodi. You will get X as plus 2. So it will be plus 2. Plus what is Y? NH3. So Y is how many are there? 4 into 2. How much you get? You will get 35. Nearest noble gas, nearest value, EN value. How the? So this is how we do it. Take another example. Let me see. The example is COCH3 6 Cl3. How do you calculate the effective atomic number? Do it. Before me, you all have to do it. EAN is equal to Z. What is Z? CO atomic number is 27 minus. What is the charge? It is on cobalt. It is plus 3. So I'll write it like this if you want. Charge is plus 3. Plus how many? 6. They are monodentate. 6 into what is the charge? Into 2. So how much you get? You get 36. Which is again the next noble gas, that is krypton. Take another example, 4, NiCO4. So nickel carbonyl. This is an example for a metal carbonyl, which is also a coordination compound. EAN value. How do you calculate? Z is 28 minus what is the charge on CO? CO is a neutral one. So 0 is the charge. Yes, 0. So 28 minus 0 plus how many? 4 are there into 2. 4 2s are 8. 28 minus 8 is how much you get? You get 36. No, 4 2s are 8. 20 you get. Yes. So this is the EAN number. Take the next example. K2 NiCN4. How do you do it? EAN is equal to, yes, what is the atomic number? 28 minus charge 2 plus 4 into 2. How much you get? You get 34. Take another example. Let me see how can you do that. So example is K3. I'll take a different CR. CR C2O4 thrice. So how do you calculate EN for this? I'll give you 1 minute of time. Do it and tell me. How do you do that? Yes, chromium atomic number is 24 minus charge on it is 3 plus 3 plus how many are there? See, that is an example for a bidentate ligand. That is an example for bidentate ligand. Mooridava, ligands 3 are there, but it is an example for bidentate ligand. Coordination number is not 3. 3 into 2. How much is the coordination number? It is 6 into 2 each electrons. Correct? So how do you do it? You will get answer 33. So this is example. Another example you take AgNH3 twice Cl. How do you calculate EAN? Atomic number of Ag is 47 minus. What is the charge on Ag? It is plus 1 plus 2 into 2. How much you get? You get 50. And this one will be for your own work. K3FeCN6. You are going to do it on your own and let me know the EAN value for this complex. Is that right? So this is how we will be calculating the effective atomic numbers for each of the following examples. Effective atomic numbers in a calculate martivi. Is that right? So coming to the next concept in coordination compounds, that is nomenclature. Nomenclature, or how to write the nomenclature of the compounds. So nomenclature of the compounds, particularly, how do we mention, how do we explain the nomenclature? Yeah. So let us see here. So there are certain rules to write the complex names of the complex compounds. What are the rules? The formula of the cation, whether it is simple or complex, is written first, followed by that of anion. This is known to us. Now simple compounds baritirtivappa. Yen compounds baritirtivi. We'll be writing the compound, say NaCl. ಈಗ NaCl ಅಂತ ಬರೆದಾಗ ಹೇಗೆ ರೀಡ್ ಮಾಡ್ತೀವಿ? ಸೋಡಿಯಂ ಕ್ಲೋರೈಡ್. ಹೌದಾ? ವಿ ರೀಡ್ ಇಟ್ ಆಸ್ ಸೋಡಿಯಂ ಕ್ಲೋರೈಡ್. See, what is sodium? Na plus 1. Chloride is minus 1. So whether we are talking about a simple ion, simple compound or a complex compound, always we write the cation first and that is followed by the anion. Same thing in case of complexes also. Complexes baribekadrunu, what we do? We write the cation first, name of the cation first, and then we write the name of the anion. Okay. Within the coordination sphere, the metal atom as well as the ligands are listed without any space between them. So when you are writing the names within the coordination sphere, this is my coordination sphere. Howda? So coordination sphere ಬಗ್ಗೆ ಬರಿತಿರ್ಬೇಕಾದ್ರೆ the metal atom as well as the ligands, they are to be listed without any space. ಅದ್ರ ನಡುವೆ ಯಾವುದು ತರದ ಸ್ಪೇಸ್ ಇರಬಾರ್ದು. There shouldn't be any space. Then, in case of ionic coordination compounds, the cation is named first and separated by the space from the anion. So illi you can see, look at this example. This example here, K4 is written first, then FeCN6. This is coordination pair. Howda? So cation modlide, anion is here. So in ionic coordination compounds, cation is named first and separated by space. When you're writing, you separate it by some space. So you can see here green ink is shown. It is separated by some space. ಆ ಸ್ಪೇಸ್ ಕೊಟ್ಬಿಟ್ಟು ಯು ವಿಲ್ ರೈಟ್ ದ ಕಾಂಪ್ಲೆಕ್ಸ್ದು ಹೆಸರು ಬರಿತೀರಿ. ಎಸ್ ಆ್ಯಂಡ್ ಐ ಟೆಲ್ ಯು. ಸೊ ಕೆ ಸ್ಟ್ಯಾಂಡ್ಸ್ ಫಾರ್ ವಾಟ್? ಪೊಟ್ಯಾಷಿಯಮ್. ಆ್ಯಂಡ್ ಹಿಯರ್ ಯು ಹ್ಯಾವ್ FeCN6. 6 ligands are there, 6 cyno ligands are there. So hexacyno, and how Fe is written, pronounced, it is pronounced as ferrate. And this number what you are seeing here, Arabic numeral what you are seeing, that is nothing but that is the oxidation number of the central metal atom. Okay, so if the coordination entity is either neutral or cationic, if the coordination entity is either neutral or cationic, then usual name of the metal is used. But when the coordination entity is an anion, the name of the metal ends with the suffix AE. Yes, andre you can see here anion complex ಇದೆ ಹೌದಲ್ವಾ? ಫಸ್ಟ್ ಎಕ್ಸಾಂಪಲ್ ಅಲ್ಲಿ ನೋಡಿ, Fe is written as what? Ferrate. It should end with ATE. Here also this is cation, this is anion. ಹೌದಾ? ಸೊ anion ಇದೆ. Cation ಆಗಿನೇ ಕಾಂಪ್ಲೆಕ್ಸ್ ಇತ್ತಪ್ಪ ಅಂತಂದ್ರೆ you will write it as platinum only. If the here also cation ಆಗಿ ಕಾಂಪ್ಲೆಕ್ಸ್ ಇದ್ದಿದ್ರೆ, this is anion ಅಲ್ಲ, anion ಬದಲು ನಾವು ಎಕ್ಸಾಂಪಲ್ಸ್ ಮಾಡ್ತಿರ್ಬೇಕಾದ್ರೆ you will see cation ಅಂತಾನೆ ಕಾಂಪ್ಲೆಕ್ಸ್ ಇದ್ದಿತ್ತಪ್ಪ ಅಂತಂದ್ರೆ you would have read it as iron. But here it is anion. ಹಂಗಿದ್ದಾಗ metal atomದು suffix ಗೆ ಏನ್ ಬರಿತೀರಿ ನೀವು? You'll write it as ATE. For example, here it is PT. ಅಂದ್ರೆ ಏನು? ಪ್ಲಾಟಿನಮ್. ಅದು ಕ್ಯಾಟೈನ್ ಆಗಿ ಕಾಂಪ್ಲೆಕ್ಸ್ ಇದ್ದಿತ್ತಪ್ಪ ಅಂತಂದ್ರೆ you would have written it as platinum only. But here it is anion ಕಾಂಪ್ಲೆಕ್ಸ್ ಅಲ್ಲಿ ಇದೆ. Therefore, you will write it as platinate. And this is the oxidation number of that platinum, right? So this is another rule of writing the coordination, naming the coordination compound. Okay, coming to some of the examples. Okay, let us take examples one by one. ಪ್ರತಿಯೊಂದು ರೂಲ್ಸ್ ನ ಅಲ್ಲೇ ಅರ್ಥ ಮಾಡ್ಕೊಂತ we will see how we can do it. Okay, fine. So let me take a new slide here. See what does the first rule says for naming the complex. Nomenclature of coordination compounds. Okay, fine. So first rule says what? First, the positive part of the coordination compound is named first. Andre positive part modal baribeku. It is named first, followed by the negative part. Correct? So positive part to complex ion irbodu, negative part to complex ion irbodu. It is immaterial. Okay, fine. Now, see, when we are talking about naming, ನೀವು ಪೈಲ ಮೊದಲು ಅದನ್ನ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಮಾಡ್ಕೊಳ್ಬೇಕು, which is the positive part and which is the negative part. Fine. Okay, then what is the next point? So what does second point says? Second point says that the ligands are named first, followed by the central metal atom. While naming the complex ion, first ligand names are written. Ligands are named first, followed by central metal atom. Okay. So ligands are named first. And if there are 2, 3, 4 ligands, then you will use 2, 3, 4 and so on idre. ನೀವೇನ್ ಯೂಸ್ ಮಾಡ್ತೀರಿ? You will use the suffix di, tri, tetra, hexa, like that you will use the suffix for ligands. Okay. Now the prefixes bis, tris, etc. are used when it includes a number. Okay, fine. In polynuclear complexes, bridging group indicates the formula. We'll see examples. Naming of the ligands. When we are naming the ligands, if there are same ligands, not an issue. Okay, naming of ligands. But ಲಿಗ್ಯಾಂಡ್ಸ್ ಬೇರೆ ತರದಿದ್ರೆ, ಹೈಡ್ರೋಲೆಪ್ಟಿಕ್ ಲಿಗ್ಯಾಂಡ್ಸ್ ಆಗಿರ್ಬೋದು ಅಥವಾ ಅಸಿಮೆಟ್ರಿಕ್ ಆಗಿದ್ದಾಗ, if there are different ligands, then how do you do the naming? The different types of ligands, the neutral, negative, positive ligands, they are named differently in the complex. When a complex species has negative charge, let me write here, when a complex species has negative charge, the name of central metal ends in name, just now ಹೇಳಿದ್ದೆ, name of central metal atom ends in ATE. ATE, this is very important. Negative charge ಅಂದ್ರೆ ಏನು? It is an anionic complex. ಇದ್ದಾಗ it will end in ATE. For some elements you use Latin names also. Okay, for example, Fe ತಪ್ಪ ಅಂತಂದ್ರೆ you write it as ferrate. Okay, then if you have Ag, you don't use the term silver here. You use the term argentate. Then if you have Cu, you write it as cuprate. Then if you have Sn, this is tin, you write it as tannate. If you have Pb, you write it as plumbate. If you have Au, you write it as aurate. ಇದು ಯಾವಾಗ anionic complex ಇದ್ದಾಗ, anionic complex metal charge ಇದ್ದಾಗ, metal is being named by ending with ATE. Point of attachment in case of unidentate ligands is very important. The point of attachment in case of unidentate ligands with more than one coordinating end, ಅಂದ್ರೆ ambidentate ligands ಇದ್ದಾಗ, how do you do the naming? Let me take an example for it to explain you. Yes, you can see here I have the example NH4 thrice. Okay, then we have Cr SCN6. This can be written also as NH4 thrice Cr NCS6. So how do we name it? This is positive ion. Okay, fine. Idu positive ide. This is negative. So this is positive, this is negative. Okay. So here, if I want to do the naming, idu same compound alli irak sadhya illa. I will change the central metal atom. I'll change the central metal atom like this. Fine. So here I'll take PT. Okay, let us try to understand. Example nodona. So NH4 positive, this is negative. So anion ide. So Cr chromium annalla now what we use the term chromate. ATE. PT platinum annalla what we use the term platinate. Fine. Up to this it is clear. Now see, this is an example for an ambidentate ligand. Howda? So here we have an ambidentate ligand where donor atom site, the point of attachment is different. Here it is through S and here it is through N. So how do we write the name for such compounds? How do you write the name? So I can write it as, what is this NH4? NH4 is ammonium. First cation has to be written. So ammonium, then leave some space. Cation ಮತ್ತು anion nadu space ಇರಬೇಕು. How many ligands are there? There are 6 ligands. So 6 stands for hexa. What is this SCN? SCN is thiocyaneto. Hexa thiocyaneto. Correct? Thiocyaneto. This is ligand. Then through which point of attachment it is done? It is through yes. ಇದನ್ನ ಬರಿಬಹುದು ಅಥವಾ ಬರಿಲಿಕ್ಕಿಲ್ಲನು. So yakantandre if you don't write it also it is okay. S. Then what is the ligand central metal atom? It is chromate and the charge on it is written as 3. So this is the name. ಇದನ್ನ ನೀವು ಹೇಗೆ ಬರಿಬಹುದು? ಮತ್ತು ಅಮೋನಿಯಂ ಹೆಕ್ಸಾ ಥಯೋಸೈನೇಟೋ ಕ್ರೋಮೇಟ್ ಅಂತಾನು ಬರಿಬಹುದು 3. Yes, 3. So this is the name. Okay. Coming to this point, what is the name? Nodi, this is ammonium. Ammonium. Positive ion is written first. Hexa isothiocyaneto. And platinate. Platinate. And the charge here is 4. I can write it like this, or I can write it as ammonium hexa. Instead of writing iso, I will write thiocyaneto. See what? Please don't get confused. Thiocyaneto space, I'll write it as N. Andre, the site of point of attachment is N. Then I'll write platinate 4. Yes. So this is how, if the point of attachment in case of unidentate ligands, ambidentate ligands iddaga, the names ಸ್ವಲ್ಪ ಹೀಗೆ change ಮಾಡಬೇಕಾಗುತ್ತೆ. Okay. Then if you have bridging ligands and all. So we will take this one by one by taking examples. Examples ತಗೊಂಡ್ಬಿಟ್ಟು ನೋಡೋಣ. So first example I'll write. We'll start with simple examples. K4 FeCN6. So this is my example. Now I want to write the name for this particular complex ion. Idak name baribekantandre what I can do. Yes, first understand. First point. Yenappa first point to understand the positive ion and the negative. So K plus is, this is positive, this is negative. That means this anionic complex negative agide. So let us write the name. So K stands for potassium. So it is potassium. Leave some space. Ligands are written first and then followed by central metal atom. So ligands, CN, cyno. How many ligands are there? 6 ligands are there. So I'll write hexa, cyno. Now, Fe cannot be written as iron. It should be written as ferrate. Hexa, cyno, ferrate. And its oxidation number is 2, which is written in Arabic numerals. Is that right? Fine. Go for the next example. Simple examples we'll try to understand. NiCO4. This is the complex. That's it. Complex ion is there. How you'll write? CO4. What is CO? Carbonyl. How many are there? 4. Therefore, I'll write tetracarbonyl nickel. And the oxidation number is 0. Tetracarbonyl nickel with 0 oxidation number. Next, Fe4, FeCN6, CN6. So how do you write the name? This is positive ion. So I'll write Fe will be written as iron. Positive ion written as it is. Iron oxidation state bandwidth to 3 here. Then complex ion hexacyano. Here I cannot write iron. I'll write it as ferrate and its oxidation number is 2. So see here. This Fe is having plus 3 oxidation state. This is having plus 2 oxidation state. Okay, fine. Then we have another example. We'll take so many examples to understand the concept. Na3CO ONO6. So it is not NO2, it is ONO. So here we are talking about ambidentate ligand. So Na stands for what? Na stands for sodium, correct? Then how many? 6. Therefore, hexa. What I'll write here? Hexanitrito. Or I can write hexanitro O. Okay. If it was NO2, I would have written hexanitro N. Here it is ONO. You can write it as nitrito, which means O is being attached, or nitro O can be written. Hexanitrito. What is this? Cobaltate. And the oxidation number is 3. Okay, fine. Go for the next example. The next example is slowly it goes on becoming complex to understand. Okay, let us not make it difficult. NH3 thrice, NO2 thrice. So this is my complex. Here there are 2 ligands. When you have 2 ligands, see, properly naming has to be done. Okay, so NH3 is named as amine. NO2 is named as nitro. Yes. So let us write the name. So it is, how many are there? 3. Nitro. Then triamine. Cobalt. 3. Yes. And when you are naming the ligands, it can be named in alphabetical order also. That is the better one. Triamine, trinitro, cobalt 3. And there shouldn't be space here, children. Please try to understand. Illi space illa. There shouldn't be space. Okay. There shouldn't be space while writing the name of ligand and the central metal atom. Okay. Let us take the next example. Fine. So the next example is PT NH3 4 Cl2 PtCl4. So please see here, both are complexes. This is positive ion, this is negative ion. So positive ion should be written first. So how do we write it? So this is written as sodium. I'm sorry. It is Pt, right? So it is platinum Yes. Tetramine. See, when I'm writing tetramine, tetramine, yes, A of tetra and A of amine, both have to be mentioned. Tetramine dichloroplatinum. The charge on this is 4. And then we have tetrachloroplatinate. See, this is the best example to understand. First, positive agi PT ide, we write it as platinum only. Negative agi PT ide, we write it as platinate. Fine. Then another example, Na2FeCN5NO. So how do you write the name? Na stands for sodium. Then 5 CN are there. So penta, cyno. Then NO is there. What is NO? Nitro. Nitrosyl. Correct? NO. Last time ligands ಬಗ್ಗೆ ಹೇಳ್ತಿರ್ಬೇಕಾದ್ರೆ I have told you. NO stands for nitrosyl. And this is ferrate with charge of 3. Yes, this is a very important example because this sodium pentacyano-nitrosyl ferrate is also called as sodium nitroprusside. It is also called as sodium nitroprusside. You can call it as sodium nitroprusside also. Frequently asked question. Yes, in the competitive part. Okay, fine. So it is also called sodium nitroprusside. Coming to the next example, CuCl2 CH3NH2 twice. So how do you write the name? CuCl2. So Cl2 dichloro. This is a complex. How the bidentate, tridentate idaga, we don't use the term bi. Here we use the term bis. So bis, what is this? Bis dimethyl amine. And this is copper with oxidation number 2. Yes. Then we have example like CONH3 thrice H2O. Okay, different ligand. Cl2. Now you can see here, this is my positive ion. Complex ion is my positive ion. And Cl is my negative ion. Hauda? Hangiddaga, what is the correction you make? Ali correction ali, you don't write cobaltate. You will write it as cobalt. Hauda? So, triamine, amine, then aqua, then you have chloro, cobalt, oxidation state banbiಟ್ಟು 3. Then last is what? Last is my chloride. Last is my chloride. Correct? So this is also a good example anta anbodu. Then you have example K2. Idanna nodidvi now. PTCl6. Can you tell me? Simple one. K2. K2 is what? Potassium. Potassium 6Cl. So hexachloroplatinate. Platinate 4. Yes. So this is potassium hexachloroplatinate. Coming to another example, K3AlC2O4 thrice. Okay. So how do you write the name? K3. K3 is nothing but potassium. Potassium 3 are there. Try. What is this C2O4? C2O4 is nothing but oxalato. So trioxalato aluminate. You will not write it as aluminium. It is aluminate with oxidation number 3. Then K3IR. Tell me this C2O4 thrice. C2O4 thrice. So this is what? This is potassium trioxalato iridium. I'm sorry, only space barbardu. Correct? There shouldn't be the space. Iridium, and the charge on iridium is 3. Take another example. Let me see how you can tell me this. COEN twice, ONOCL, close the bracket, Cl. Can you take a second to tell me the name for this compound, this particular complex? Yes, so this is positive ion, this is negative, so you'll write it as cobalt. That is done. Fine, what will be the name? So we will start with chloro. This is a bidentate ligand, En. Therefore, chlorido. It is not chloro, it is chlorido. Bis. What is En? Ethane 1, 2 diamine. Yes. Then nitro O. You can write it as nitro O or you can write it as nitrito. Then cobalt. I'll not write it as cobaltate. It is cobalt 3. And finally, chloride. How the? This is the name. Is that right? Fine. Take the next one. Slowly it is getting difficult, Allah. But the examples, how many examples you will solve, that much clearance it will be. Okay, fine. So next example, NH4 thrice Cr, again SCN6. Tell me the name. NH4 stands for ammonium. Ammonium. 6 SCN, hexa thiocyanato S chromate, and the oxidation number is 3. Yes. Then another example, NH4 thrice, NH4 twice. Okay. Then here you have PT, NCS6. Okay. So how do you write the name? Ammonium hexa. You will write it as isothiocyato platinate. Platinate 4. Yes. Take another example. Few more examples. Let us do it. Come on. Do it along with me. CuNH3 4 SO4. Okay. Positive ion. So tetra amine. Cu stands for copper. Atomic, the oxidation state 1 bit is 2 and SO4 is sulfate. How the? This is the name. Fine. Then CuH2O 4 times Cl2 Cl dot 2H2O. Okay, let us try to understand now. See, 2H2O is there. Fine. ಹೇಗೆ ನೇಮ್ ಬರೆಯೋದು ಇದ್ರದ್ದು? Take a moment and tell me, can you do it? I'll give you one more example. Here, make it as Cr. Okay. Cr H2O4 Cl2 Cl. Okay. Take the another example. Cu H2O4 SO4 H2O. Okay. How do you write the names for this? Tell me. Come on. Think and answer. So here Cr H2O4. H2O4 andaga it is tetra aqua. Howda? So tetra aqua. Fine. Then you have Cl2. Cl2 andre dichloro. Then Cr. Cr stands for chromium. Itrdu oxidation state banbitu 3. Then you have chloride. CHLORIDE, chloride. And then you have 2 water molecules. So I'll write 2 water. Just like this, you are going to represent it. Fine. Similarly here, what you'll write? Tetra aqua, then copper 2, then SO4, sulfate, and then 1 water. That is 1 water molecule is there. Fine. Now, if you have certain bridging complexes and all, like for example, the complex goes something like this. NH3 5 times CO, NH2, CO, NH3, 5. Then you have NO3, 5. So while naming the bridging groups, mu term is being used. Bridging group. This is CO is being bridged here. Yes. So while naming the bridging groups, what you use the term mu. Bridging group ide anta artha. So mu, I'll write it like this. So the name of the compound is, so mu. See, how can I write the name? Mu states that while you are naming the bridging complex. So mu, it is written as amido NH2. And how many bridges are there? Two. How many are attached? Two. Therefore, they are complexes. I'll write bis bracket. So how many NH3 are there? 5. So penta amine. Which is the central metal atom? It is cobalt. The charge carried by it is 3. And then outside the thing is what? Outside it is NO3 group. And that NO3 group is called what? NO3 is nothing but nitrate. It is nitrate. Similarly, you can do one more example. I'll give you NH3, 5, CO, OH, CO, NH3, 5, Cl5. So come on, tell me how you can do it. ಹೇಗ್ ಮಾಡ್ಬೋದು ಹೇಳಿ ನೋಡೋಣ. If you have a bridging compound here, then how you will do the naming? Okay, how you will do it? So it is started with like this. You will use the term, when it is a bridging compound, you will use the term mu. Howda? Mu hydroxo OH group is there. Central agirod madal baribeku. Hydroxo. 2 are attached. Therefore, again, I'll use the term bis. Then, bracket ali, pentamine, pentamine. So, cobalt is there. Cobalt. The complex coordination number is 3 again. And outside is chloride. Outside is chloride. Correct? So, this is how we do the naming. If it is bridging compound. So bridging compound ilapa, we have different compound, like say CONH3, 6, CrCN6, close. So how do you do the naming for this compound? How do you write the name for this compound? Yes. So how do you write it? This is cation. So it is hexamine, cobalt 3, then hexacyanochromate, chromate 3. Correct? This is how we write the name for the compound. Take another compound. COONO NH3, 5, Cl2. Or I'll give you the compound CONO2 NH3, 5, Cl2. How do you write the name for this? Heg baritiri his name hedi. Yes, the names, it is written like this. So pentamine, nitrito, cobalt 3, chloride. Howda? And here you write it as pentamine, nitro, cobalt 3, chloride. Is that right? So these are some of the examples to make you all understand how do you do the nomenclatures. And here are few more examples. You can see LiAlH4, lithium H4. H stands for hydrido. Yes, lithium hydridoaluminate. Lithium hydridoaluminate. Na3 ಅಥವಾ tetrahydridoaluminate ಅಂತಾನೂ ಅನ್ಬೋದು. Then Na3CO, 6 is there. So Na3 is not what? Na3 is sodium. So sodium, then 6 NO2 are there. So hexa nitrito N. N stands for what? N stands for nitrogen is the point of attachment. Okay, ಅಥವಾ ನೈಟ್ರೋ ಅಂತಾನು ಬರಿಬಹುದು, ಏನ್ ಬರೀಲಿಲ್ಲ ಅಂದ್ರೂ. Cobaltate with the oxidation number 3. AgNH3 twice NO. Diamine silver 1 nitrate NO. KAuCN4 minus. So K stands for potassium. CN4 tetracyano negative anion ide. So you will write orate 3 ion because there is minus sign being shown. NiCN4 minus 2 tetracyanonickelate because it is minus 2 charge, that means it is an anion. So tetracyanonickelate 2 ion. Yes, so this is how nomenclature of the compounds is being done. Hope the nomenclature part I have made quite clear. There is this. So if you go on solving many examples, you will try to understand it in a better way. Adashtu examples solve ಮಾಡಿ I have maximum examples na ನಾನು ತಗೊಂಡಿದ್ದೆ. Still take different books and try to solve the examples so that you will become perfect. I hope the nomenclature part and whatever we discussed today are crystal clear. We will be talking about isomerism in the coordination compounds and different theories behind the coordination compounds in our next class. For now, thank you.